Have you ever wondered what the future of lunar exploration holds? Imagine astronauts walking on the moon once again, but this time, it's not just a visit, it's the beginning of humanity's long-term presence on our closest neighbor. What if the moon could become a launch pad for missions to Mars? In 2025, we're about to witness some of the most exciting lunar missions ever. From international collaborations to groundbreaking technology, the moon is set to become the center of space exploration. Are you ready to explore what's coming next? Let's dive in. NASA's Artemis program. The excitement surrounding NASA's Artemis program is palpable as we edge closer to a new chapter in lunar exploration. The Artemis mission is not just a return to the moon, it's a stepping stone for humanity's journey to Mars and beyond. The Artemis II mission, scheduled for 2026, will be the first crewed flight around the moon since Apollo 17, marking an incredible milestone. 4 astronauts will embark on this historic journey, orbiting the moon before returning to Earth. Imagine the thrill of seeing our Earth from space once again, just like Apollo astronauts did decades ago. But what makes Artemis III, set for 2027, even more exciting is its ambition to land astronauts near the lunar South Pole. This is no ordinary landing site. The South Pole is a treasure trove, believed to contain vast amounts of water ice. This ice could potentially fuel future missions and even support a sustainable lunar presence. For the first time in history, we'll be walking on an uncharted part of the moon. NASA's ambitious plans go beyond just visiting. They're focused on building a sustainable lunar presence with habitats, scientific outposts, and resource mining, all key for preparing us to explore the Red Planet. The Artemis program is set to revolutionize not just lunar exploration, but the entire future of space travel. With technology, innovation, and international collaboration on its side, Artemis is paving the way for a new era of space exploration. Get ready to be part of history in the making. China's Chang'e missions. China's Chang'e missions are pushing the boundaries of lunar exploration, and 2025 promises even greater strides. The Chang'e 6 mission, launching in 2025, will make history by returning lunar samples from the moon's far side, an area that has never been explored by humans. This mission will touch down in the moon's South Pole Aitken Basin, one of the largest and most ancient impact craters in the solar system. Scientists believe this region holds answers to the moon's earliest history and secrets about the formation of the solar system. The Chang'e 6 mission represents more than just a scientific venture, it's a step toward China's ambition to lead in space exploration and lunar development. But that's just the beginning. By bringing back lunar samples from an untouched region, China will help scientists around the world unlock secrets about the moon's composition and the presence of water ice, which could be used for fuel and other resources in future missions. China's growing space presence will enhance international collaboration, especially as it partners with other nations to share data and findings. The Chang'e program is not only about exploration, it's also about sustainability. As China looks to build on its achievements and create a permanent presence on the lunar surface, Chang'e 6 is poised to deepen our understanding of the moon and reshape the future of lunar exploration for generations to come. India's Chandrayaan missions. India's space agency ISRO has been making remarkable strides in lunar exploration, and the next chapter of this journey is incredibly exciting. Following the success of Chandrayaan-2, which placed a rover near the moon's south pole, India is setting its sights even higher with Chandrayaan-4, set to launch by 2027. The success of Chandrayaan-3 in 2023, which landed near the South Pole, made India only the 4th country in history to achieve a soft landing on the moon. This achievement has not only positioned India as a rising space power, but has also opened up incredible scientific opportunities. Chandrayaan-4 will be even more ambitious, with plans to return lunar samples to Earth. These samples will help us understand the moon's geological history and its potential to support future lunar missions. But there's more. ISRO's focus on the moon's south pole is crucial because this region contains water ice, one of the most valuable resources for sustainable space exploration. India's lunar missions are poised to contribute vital data on the moon's resources and how they can be used for future space exploration. As part of an international lunar science community, India is playing a pivotal role in unlocking the moon's secrets. The Chandrayaan missions are paving the way for India to not only contribute to lunar science, but to become an essential player in the exploration of our solar system. India's lunar ambitions are just beginning, And the next mission is sure to push the boundaries of what we know about Earth's closest neighbor. Commercial lunar landers. The future of lunar exploration isn't just about governments, it's also about private companies stepping up to the challenge. In 2025, we're going to see more private sector involvement than ever before, with commercial lunar landers like Intuitive Machines and Astrobotic leading the charge. These companies are not just launching payloads into space, they are taking humanity a step closer to creating a permanent lunar presence. Intuitive Machines' IM-2 mission, set to launch early in 2025, will land near the Shackleton crater, a region that holds clues about the moon's water ice deposits. This mission will open doors to the exploration of lunar resources that could one day be used for fuel, water, and life support on the moon. Astrobotic's Griffin 1 mission, scheduled for late 2025, is another milestone in private lunar exploration. This mission will deliver scientific payloads to the moon, including experiments and technologies that could be vital for establishing a sustainable lunar infrastructure. The rise of commercial companies in lunar exploration signals a new era, one where private enterprise plays a major role in space exploration. These companies are helping to drive innovation, reduce costs, and make space more accessible. In fact, many experts predict that commercial lunar landers will not only change how we explore the moon, but will also play a critical role in future Mars missions. The partnerships between private companies and space agencies are forging a path toward a future where lunar exploration isn't just for a select few but is a global effort. The possibilities are limitless, and the moon is just the beginning. International collaborations. As the race to the moon accelerates, international collaborations are becoming a crucial part of the lunar exploration landscape. These partnerships are not just about sharing the costs of missions, but about combining the expertise, technology, and resources of multiple nations to achieve something greater than any one country could accomplish on its own. In 2025, we will witness some of the most exciting joint lunar missions, with countries like India, Japan, and even the United States teaming up for groundbreaking research and exploration. One such collaboration is the Joint Lunar Polar Exploration Mission, which India and Japan are developing. This mission will focus on the lunar South Pole, an area that holds vast reserves of water ice, one of the most valuable resources for sustaining human presence on the moon. By joining forces, these nations will combine their scientific and technological capabilities, ensuring that the mission is as successful as possible. The data collected will be vital for understanding the moon's resources and creating a sustainable future for lunar exploration. These international partnerships are more than just about scientific discovery. They're about building a united front for the future of space exploration. As nations collaborate on the moon, they are also laying the groundwork for future cooperation on Mars, asteroids, and beyond. The exchange of knowledge, technology, and expertise ensures that all countries involved benefit, while the collective achievement of humanity is pushed further into the cosmos. The moon has always been a symbol of human curiosity and ambition, but now it's also a symbol of collaboration. And as we work together to uncover its secrets, we also work toward building a future where space exploration is a global endeavor. Future lunar infrastructure. The vision for the moon is rapidly transforming from short-term missions to long-term infrastructure. The Lunar Gateway, a project initiated by NASA, is set to play a pivotal role in this transformation. This space station, positioned in lunar orbit, will serve as a staging point for crewed missions to the moon and beyond. The Gateway will provide astronauts with a safe and reliable location to dock, refuel, and resupply before heading to the moon's surface. This infrastructure is crucial for creating a sustainable human presence on the moon, and will be key in our efforts to explore Mars and other parts of the solar system. But the Gateway is only one part of the bigger picture. To support long-term lunar exploration, there's a need for advanced technology that can harness the moon's resources. NASA, along with other space agencies, is developing systems to extract water from the moon's ice deposits and use it for fuel, oxygen, and even drinking water. This technology is vital for sustaining astronauts on extended missions. Additionally, research into building habitats using lunar soil is underway, as this will allow for the creation of permanent lunar bases that can support future generations of astronauts. These efforts are laying the foundation for a self-sustaining lunar outpost that doesn't rely on Earth's resources. The goal is not just to visit the moon, but to build a lasting presence that can support human life and serve as a launchpad for further space exploration. With the right technology, international collaboration, and a focus on sustainability, the moon will become humanity's stepping stone to the stars. As we lay the groundwork for this future, we're not just expanding our reach into space, we're securing humanity's place as a multi-planetary species. So there you have it. 2025 is shaping up to be an incredible year for lunar exploration. With groundbreaking missions, international partnerships, and cutting-edge technology, the moon is closer than ever to becoming humanity's next frontier. What do you think the future holds for lunar missions? Let us know in the comments. Don't forget to like, share, and subscribe to Space Facts for more exciting updates on space exploration. The cosmos is full of wonders, and we're here to uncover them together. Until next time, keep looking up. Have you ever wondered what the universe is truly made of? What if everything you see around you, every star, planet, and even you, wasn't made of particles but tiny, vibrating strings? Sounds impossible, right? But string theory proposes just that. The idea that the fundamental building blocks of everything are one-dimensional strings, vibrating in ways we can barely imagine. What if this theory could explain everything, from gravity to the forces that govern atoms? In today's video, we'll dive deep into string theory and explore its mind-bending concepts. So, are you ready to unravel the mysteries of the universe? What is string theory? Imagine for a moment that the entire universe, everything you see around you, is not made of solid particles, but rather something far more mysterious. What if, at the most fundamental level, everything, from the tiniest atom to the vastest galaxy, is made up of tiny vibrating strings? That's the essence of string theory, a revolutionary idea that suggests the basic building blocks of the universe aren't particles like we've always thought, but these minuscule one-dimensional strings. Now let's break this down. Picture a guitar string vibrating. Depending on how it vibrates, it produces different notes, right? Well, according to string theory, the vibrations of these strings determine the properties of particles like quarks and electrons, particles that make up everything in the universe. These strings are unimaginably tiny, so much so that they're smaller than even atoms. And just like different vibrations on a guitar string produce different sounds, the different vibrations of these strings give rise to all the different particles and forces that govern the universe. It's a bold claim, isn't it? It challenges everything we've been taught about what makes up the fabric of reality. But what's fascinating about string theory is that it brings a fresh perspective. If we could understand how these strings vibrate, it could be the key to understanding everything. The forces that bind atoms together, the way particles interact, even the force of gravity itself, all of it could be explained by the behavior of these tiny vibrating strings. So let's journey deeper into this world of strings and see how they could change our understanding of the universe. The four fundamental forces. We all experience the world through the lens of four fundamental forces. Gravity pulls everything downward. Think of the apple falling from the tree. Electromagnetism is what makes your phone light up, or a magnet stick to your fridge. The strong nuclear force holds the nucleus of atoms together, and the weak nuclear force governs radioactive decay. But here's the thing. Even though these forces shape everything in our universe, they don't fit neatly into the same framework. Each of these forces operates on different scales, with different rules. Gravity works on large scales, holding planets and stars in place, while electromagnetism governs the behavior of charged particles like electrons. The nuclear forces, on the other hand, are confined to the tiny space within atoms. But what if they could all be part of the same system? String theory suggests exactly that. These forces may have once been unified, existing together as a single force right after the Big Bang. It's a mind-blowing thought that these forces, so different in how they act, might have all come from the same source. String theory proposes that at very high energies, like those just after the birth of the universe, these forces were united in a single, elegant force. As the universe cooled, they separated, and over billions of years evolved into the four distinct forces we observe today. But here's where it gets exciting. String theory doesn't just unify these forces, it could potentially explain why they operate the way they do. If we could understand how they evolved from 1 to 4, we could unlock answers to some of the most profound mysteries in physics. Could string theory be the key to this unification? That's the question scientists are trying to answer today. Unification of forces. Imagine this. All the forces of nature, the ones that govern everything from the tiniest particle to the largest galaxy, could at one point have been unified, existing as a single force. It sounds like science fiction, but it's a real possibility according to string theory. The idea of force unification suggests that, in the early moments of the universe, right after the Big Bang, gravity, electromagnetism, and the nuclear forces, strong and weak, were not separate entities as we know them today. Instead, they were part of a singular force that existed in harmony, working together as one. Now, picture this force like a tightly wound spring. As the universe began to cool and expand, this single force began to stretch out, cooling down and splitting into different forces over time. So, gravity, which governs massive objects like planets and stars, separated from the electromagnetic force that powers electricity and magnets. Similarly, the strong nuclear force responsible for holding atomic nuclei together, and the weak nuclear force responsible for radioactive decay, broke off from each other as well. What string theory proposes is that if we can uncover how these forces were unified, we might understand not only the origins of the universe but also a deeper connection between everything that exists. All of the laws that govern the universe could have come from this one unified force. The theory also suggests that, under extreme conditions like those found inside black holes or in the first moments of the universe, these forces might merge again. If we could access that information, we could potentially create a theory of everything, unifying all the forces of nature into a single framework. Could string theory hold the key to this ultimate unification? That's the journey scientists are currently on. Extra dimensions. String theory isn't just about small strings vibrating in a big universe. It takes us beyond the familiar dimensions of space and time. You see, we are accustomed to thinking in terms of 3 dimensions of space: up, down, left, right, and forward, backward, and 1 dimension of time. But in the world of string theory, that's just the beginning. To make sense of how the theory works, we need to accept the existence of extra dimensions, dimensions beyond the ones we can see, feel, or even imagine. Now don't panic. These extra dimensions aren't something you can just walk into. In fact, string theory proposes that these extra dimensions are compactified. They're tiny and folded up in a way that makes them undetectable with our current technology. In essence, these dimensions are hidden from our everyday experience, existing at scales so small that they're invisible to even the most powerful microscopes. But why extra dimensions? Well, it turns out that these dimensions are critical for string theory to be mathematically consistent. Without them, the strings wouldn't be able to vibrate in a way that explains all the particles and forces in the universe. Some versions of string theory even propose that there could be as many as 7 extra dimensions beyond the ones we know. These dimensions might be compactified in shapes called Calabi-Yau manifolds, fancy terms for the intricate geometric shapes that these dimensions could take. But while we can't see or directly interact with these extra dimensions, they could play a huge role in how the universe operates at its most fundamental level. If we could somehow uncover more about these hidden dimensions, it might unlock some of the deepest mysteries of physics, leading us to a fuller understanding of everything that exists. Supersymmetry. Imagine a world where every particle you know, every quark, electron, and photon, has a mysterious twin, a superpartner. This is where supersymmetry steps in. It's a concept within string theory that suggests that for every particle, there's a corresponding particle with different spin properties, often referred to as its superpartner. At first, it sounds a bit like science fiction, like something out of a superhero movie. But supersymmetry isn't just an intriguing idea, it's a crucial piece of the puzzle in string theory. You see, the fundamental particles we know today don't quite fit into the elegant equations that describe string theory. Enter supersymmetry, which smooths out some of these inconsistencies and helps bring string theory's predictions into alignment with reality. Now let's dive a bit deeper. Every particle in the universe has a property called spin, a fundamental characteristic that affects how the particle behaves in relation to other particles and forces. Particles like electrons, which are fermions, have half-integer spins, while force carriers like photons, the particles of light, are bosons with integer spins. According to supersymmetry, each fermion has a boson counterpart, and each boson has a fermion counterpart. This pairing helps to balance out equations and resolve some of the mathematical problems in string theory. While we haven't observed these superpartners yet because they're expected to exist only at very high energy scales, far beyond current technological capabilities, The idea of supersymmetry provides an elegant way to potentially explain some of the gaps in our understanding of the universe. If supersymmetry holds up under experimentation, it could open new doors in understanding particle physics and even the elusive concept of dark matter, the invisible substance that makes up a huge part of the universe's mass. Supersymmetry could very well be the key to unlocking mysteries we've been chasing for decades. Challenges and criticisms. As mesmerizing and elegant as string theory sounds, it's far from perfect. In fact, it faces a number of challenges and criticisms that have made many scientists hesitant to fully embrace it. And the biggest issue? The lack of experimental evidence. For any scientific theory to be accepted, it needs to be testable, something that can be observed, measured, and verified. However, string theory operates on such a small scale, far beyond what we can currently observe. The energy levels required to test the predictions of string theory are so high that even the most advanced particle accelerators, like the Large Hadron Collider, cannot reach them. This means that right now, we don't have a way to directly test whether string theory's predictions hold up in the real world. But that's not the only hurdle. Another criticism of string theory is the vast number of possible solutions it proposes. Depending on how you interpret the theory, string theory could describe an almost infinite number of possible universes, each with its own unique set of physical laws. Some critics argue that this makes string theory more of a mathematical framework than a truly predictive theory. Essentially, it's so flexible that it can explain anything. This makes it difficult to pin down a definitive prediction that could be tested. And then, there's the complexity. String theory involves highly advanced mathematics. Sometimes it feels like we're using abstract equations to describe things that we can't see or touch. For many, it feels more like an intellectual exercise than a practical theory that could be tested. Some even argue that scientists are chasing something that may never be testable, leading them away from more immediately fruitful areas of research. Despite these challenges, string theory continues to inspire physicists. The elegance and potential of unifying all forces into a single framework still resonate with many. And though we may not have all the answers now, the journey to understand the universe on its most fundamental level could take us to new frontiers of physics. Whether or not string theory becomes the ultimate theory of everything remains to be seen, but the pursuit of it is, without a doubt, an exciting chapter in the story of science. And that's a wrap on today's dive into the fascinating world of string theory. While it might seem like something straight out of science fiction, it's a theory that could change everything we know about the universe. What do you think? Could strings be the key to understanding the forces of nature? Let us know your thoughts in the comments below. If you enjoyed this journey into the unknown, don't forget to like, share, and subscribe for more amazing space facts. Until next time, keep looking up because the universe has so much more to reveal. Every atom in your body was once part of a star that lived and died long ago. That's not poetry, it's science. The stars above aren't just beautiful, they're the reason we exist. We are literally made of star stuff. Ancient civilizations worshipped them. Today, we know stars are born, they burn, and they die in explosions so powerful they reshape galaxies. So when you look up tonight, ask yourself, what are you really seeing? A light show, or the history of everything? Let's uncover the life and death of the stars and why their story is also ours. The birth of a star. Stars are born in the cold, dark expanses of space within massive clouds of gas and dust known as nebulae. Imagine these nebulae as vast cosmic nurseries where the ingredients for new stars are scattered across the universe. These clouds contain the raw materials, hydrogen, helium, and dust particles, that, when compressed under the immense force of gravity, can give birth to something incredible. Gravity is the star's first catalyst. It slowly pulls the gas and dust together, causing the particles to collide and condense, making the cloud denser and hotter. This process takes thousands to millions of years, depending on the size of the nebula. As the gas and dust compress, a new hot and dense core forms at the center called a protostar, but it's not quite a star yet. The protostar is still in the process of gathering mass and energy. The temperature and pressure inside this core continue to rise, and once they hit around 15 million degrees Celsius, something incredible happens. Nuclear fusion ignites. This is the moment when a star is truly born. Hydrogen atoms in the protostar's core start to fuse into helium, releasing vast amounts of energy. This fusion creates light and heat, causing the star to shine brightly. And just like that, a new star is lighting up the cosmos. The process continues, and as the star stabilizes, it enters the main sequence phase, which can last for billions of years. Stars may begin from the most ordinary of elements, but through the forces of gravity, pressure, and time, they evolve into shining beacons in the night sky, marking the birth of something far greater than just light. It's the beginning of a stellar life cycle that will span millions, sometimes billions of years. Main sequence. After a star is born and nuclear fusion takes hold, it enters what we call the main sequence phase. This is the star's stable period, where it spends the majority of its life. Think of it as the star's middle-aged phase, where everything is calm, stable, and most importantly, shining. The star is constantly fusing hydrogen atoms into helium in its core, a process that releases an incredible amount of energy. This energy is what powers the star and gives it its brilliant light. For a star like our Sun, the main sequence lasts for about 10 billion years. That's right, a star is in this phase for a very long time. During this phase, the star has reached a perfect balance. On one side, the energy produced by nuclear fusion creates outward pressure, which tries to expand the star. On the other hand, gravity pulls inward, trying to collapse the star. These two forces, gravity and fusion, counterbalance each other perfectly, keeping the star stable and glowing. For most stars, this is the longest period of their lives. They shine steadily, providing light and heat to their surrounding planets, and if they're lucky enough, they might even give rise to planets with life, like Earth. The main sequence is an incredibly important phase in the life of a star. It's during this time that stars reach their full luminosity, and for us on Earth, it's what allows the stars in the night sky to shine brightly. But just like every good thing, the main sequence phase must eventually end. But before we dive into what happens when the star runs out of fuel, let's just take a moment to appreciate this balance that makes stars like our Sun such essential players in the cosmic drama. This phase represents the peak of a star's vitality, and without it, the rest of the stellar journey wouldn't even be possible. Red giant phase. As a star like our Sun enters the later stages of its life, its hydrogen fuel in the core begins to run low. But don't think that means the end is near. This is just the beginning of one of the most dramatic changes a star will undergo. When the hydrogen runs out, the core starts to contract under gravity's pressure, and in response, the outer layers of the star begin to expand, cool, and take on a reddish hue. Welcome to the red giant phase, where the star grows into a colossal, glowing sphere. At this point, the star's core is much hotter than before, which allows the fusion of heavier elements like helium. As helium atoms fuse together, they form carbon and oxygen, and the fusion process generates even more energy. This energy causes the outer layers of the star to expand massively. In fact, a red giant can grow to be hundreds of times the size it was during its main sequence phase. If our Sun were to go through this stage, it would expand so much that it could engulf Mercury, Venus, and even Earth. Imagine our planet, once teeming with life, now being swallowed by a massive red-hot ball of gas. But even as the star swells in size, things are beginning to change beneath the surface. The increased temperature causes the outer layers to become unstable, leading to massive stellar winds that blow away the star's outer material. In some cases, these winds can carry away up to a third of the star's mass. As the star grows, it starts to shed its outer envelope, leaving behind a dense core. This core will eventually become what's known as a white dwarf, the next phase in the star's journey. While this red giant phase might seem chaotic, it's actually one of the most fascinating stages in a star's life. The transformation from a stable, burning furnace into a massive, unstable behemoth is an awe-inspiring sight, and it's during this time that some stars make their most significant contributions to the universe, creating the heavier elements needed for future star systems and planets. Supernova explosion. For stars that are much more massive than our Sun, the red giant phase is just the beginning of a fiery and explosive end. These stars, once they have exhausted their core hydrogen, undergo a more dramatic and intense series of events that lead to the birth of one of the most magnificent phenomena in the universe, the supernova. But how does this happen? It all starts when the core of a massive star starts fusing heavier elements like carbon, neon, and oxygen into even heavier elements like iron. However, when the core finally forms iron, something changes. Unlike lighter elements, iron cannot undergo fusion to release energy. This creates a major problem for the star. Without the energy from fusion to counteract gravity, the core begins to collapse. The pressure from this collapse causes the outer layers of the star to implode inward at incredible speeds. As the outer layers crash into the dense core, they are thrown outward in a cataclysmic explosion. This is a supernova, a violent, explosive event that releases more energy in a single burst than our Sun will release throughout its entire lifetime. The explosion is so powerful that it can briefly outshine an entire galaxy. During this brief period, the supernova becomes the brightest object in the sky, visible across vast distances. These explosions scatter the star's outer layers into space, enriching the interstellar medium with heavy elements like gold, uranium, and iron. Elements that are crucial for the formation of planets, life, and everything we see around us. Supernovae are essentially the universe's recycling process, creating new building blocks for future stars and planetary systems. But not every star dies the same way. While smaller stars will collapse into white dwarfs, the most massive ones undergo an even more fascinating fate: a neutron star, or, if the mass is great enough, a black hole. But before we delve into these stellar remnants, let's pause and appreciate the sheer cosmic power of a supernova. It's a spectacular end to a star's life and a beautiful beginning for the next generation of stars and galaxies. Stellar remnants. When a massive star explodes in a supernova, it doesn't just disappear into nothingness. What's left behind is a dense, compact remnant that is often more fascinating than the explosion itself. The fate of this remnant depends entirely on the mass of the star's core. There are two possible outcomes for the surviving core: a neutron star, or, if the core is heavy enough, a black hole. Neutron star. For stars with a core mass between roughly 1.4 and 3 times that of the Sun, the core doesn't collapse into a black hole. Instead, it becomes a neutron star, a celestial body so dense that its atoms essentially collapse into neutrons. A neutron star is incredibly small, with a radius of only about 10 kilometers, yet it packs more mass than our Sun. This density means that the star's gravitational field is extreme, and neutron stars are known to emit intense magnetic fields and fast-spinning beams of radiation, which we detect as pulsars. These pulsars can spin up to several hundred times per second, creating a cosmic lighthouse effect. Imagine the power of a star compressed into such a tiny, dense object. For stars with a core mass greater than about 3 solar masses, no amount of pressure can prevent the collapse. The core continues to shrink, becoming so compact that it forms a singularity, an infinitely small point with immense density. This process creates a black hole, a region of space where gravity is so strong that not even light can escape. A black hole doesn't suck everything around it like in the movies, but its gravitational pull is so strong that anything that ventures too close gets pulled in, never to escape. Black holes are mysterious and elusive, but they play a crucial role in shaping galaxies, as most large galaxies have a supermassive black hole at their center. These objects are both fascinating and terrifying, and we can only begin to imagine the mysteries they hold in the depths of their gravity wells. White dwarfs. While the fate of massive stars is marked by dramatic explosions and mysterious remnants, the path of smaller stars, those with less than 8 times the mass of our Sun, is equally fascinating but less violent. Instead of blowing up in a supernova, these stars end their lives as white dwarfs. For stars like our Sun, the transformation into a white dwarf is a quieter, more gradual process, but no less important in the cosmic cycle. When a star like our Sun runs out of hydrogen fuel in its core, it begins to shed its outer layers, releasing a glowing shell of gas and dust known as a planetary nebula. What's left behind is the core of the star, which becomes the white dwarf. A white dwarf is a small, dense object about the size of Earth, but with a mass comparable to that of the Sun. This incredibly dense remnant is made primarily of carbon and oxygen, supported against further collapse by electron degeneracy pressure, a quantum mechanical force that arises from the Pauli exclusion principle. In simple terms, this pressure prevents the electrons in the white dwarf from being squished together. Over time, white dwarfs slowly cool and fade, becoming dimmer and dimmer over billions of years. Eventually, they will no longer emit any light or heat, leaving behind a cold, dark relic of the once glowing star. These white dwarfs are not completely lifeless, though. In fact, the elements they contain are some of the building blocks for new stars, planets, and even life. The cosmic recycling process continues as the white dwarf's remnants, its carbon and oxygen, might eventually become part of a future generation of stars or planets. Even in death, the star has a profound impact on the universe, passing on the elements needed for new life to take shape. Stars with lower mass end their lives not with a bang, but with a whisper, a slow, silent fade into the cosmic background. But even in their quieter demise, they play a vital role in the ongoing creation of the universe. The cosmic recycling. The death of a star, whether through a supernova explosion, the slow fading of a white dwarf, or the quiet collapse of a neutron star, is not the end of the story. In fact, it's only the beginning of a new chapter in the universe's vast and ongoing cycle of creation and destruction. The elements that were once forged in the heart of a star, hydrogen, helium, carbon, oxygen, iron, and more, are scattered throughout space, enriching the interstellar medium and becoming the building blocks for the next generation of stars, planets, and even life. When a massive star dies in a supernova, the explosion blasts these elements into space at incredibly high speeds, often faster than the speed of light. This cosmic spray of material can travel across vast distances, carrying with it the very elements that are essential for the formation of new stars and planets. For example, our own solar system was likely formed from the remnants of earlier supernovae. The heavy elements that make up the Earth, including the iron in our cores and the oxygen in our atmosphere, were born from the death of ancient stars. Without these stellar deaths, life as we know it would not exist. But it's not just supernovae that contribute to this cosmic recycling process. White dwarfs, the remnants of medium-sized stars, also play a role in this cosmic game of life and death. Over time, as white dwarfs slowly cool and fade, they might still release their residual elements into the surrounding space. These elements could be incorporated into new star-forming nebulae, further fueling the creation of new stars and planets. Moreover, neutron stars and black holes, while seemingly the ultimate end for a star, are not entirely disconnected from the cycle of stellar creation. For example, neutron stars can emit strong bursts of radiation known as gamma-ray bursts, one of the most powerful phenomena in the universe. These bursts of energy can trigger the formation of new stars in distant regions, essentially reigniting parts of the galaxy into new life. Even black holes, with their immense gravitational pull, can influence the formation of new stars by pulling in nearby gas and dust, providing the necessary material for star formation in a process known as accretion. Thus, the death of a star is not a solitary event, it is an essential part of a greater cosmic cycle. Each time a star dies, it releases the ingredients for new beginnings, new stars, new planets, and potentially even new life. The universe, it seems, is forever recycling itself, and each stellar death is a crucial step in this ongoing process of creation. The birth and death of stars are, in a sense, two sides of the same coin, forever linked in the vast, ever-changing tapestry of the cosmos. Thanks for joining me on this incredible journey through the life cycle of stars. From their dramatic births in swirling clouds of gas to their spectacular deaths that seed the universe with new elements, stars truly shape everything around us. The next time you look up at the night sky, you'll see more than just points of light. You'll see stories of creation, destruction, and cosmic rebirth. Stay curious, keep looking up, and keep wondering about the vast universe we call home. And if you love discovering the secret of the universe, don't forget to like, subscribe, and hit the bell icon for more adventures. Since the dawn of civilization, humans have stared at the stars, yearning to understand our place in the vast cosmos. Ancient astronomers mapped the heavens with curiosity and awe, while today's scientists have uncovered a stunning truth. The universe isn't just expanding, it's accelerating. Yet the biggest question still looms larger than galaxies themselves. What ultimate destiny awaits the universe? Will it stretch endlessly into an icy dark void, or could it one day collapse in a fiery cosmic finale? Join me as we unravel this breathtaking mystery where science meets the edge of imagination, and the future of everything hangs in the balance. The cosmic question. What if I told you the universe is not just expanding? It might be racing toward a fate so strange and mysterious that it challenges everything we know about time, space, and existence itself. This isn't science fiction or a far-off fantasy. It's a cosmic puzzle that has captivated scientists, philosophers, and curious minds for decades. Will the universe stretch endlessly, growing colder and emptier until nothing remains? Or could it one day reverse course and collapse back in on itself, like a giant cosmic heartbeat pulsing through time? Or perhaps even more unsettling, might it tear itself apart atom by atom, unraveling the very fabric of reality? These mind-boggling possibilities sound like something out of a sci-fi novel, yet they come directly from the most cutting-edge research in astrophysics and cosmology. Today, we're embarking on a journey to explore one of humanity's most profound and thrilling questions. What is the ultimate destiny of our universe? Whether you're someone who loves gazing at the stars or simply want to understand the future of everything around us, this adventure will guide you through astonishing theories, surprising facts, and the mind-bending nature of space itself. So prepare your imagination and curiosity, because the fate of the universe may be far stranger and more fascinating than anything you've ever imagined. The Big Bang and the beginning of expansion. Almost 13.8 billion years ago, the universe had its dramatic beginning, not with a bang as the name suggests, but from an unimaginably hot, dense point smaller than an atom. This moment, known as the Big Bang, set everything in motion. From this tiny speck, space itself began to stretch and expand, creating the cosmos we call home. Early on, the universe grew at an astonishing pace during a phase called cosmic inflation, where it ballooned exponentially in a fraction of a second. This rapid expansion smoothed out the universe, setting the stage for galaxies, stars, and planets to form billions of years later. What's remarkable is that this expansion didn't happen in space. Rather, space itself expanded, carrying everything along like dots on an inflating balloon's surface. Scientists have traced back this expansion through observations like the cosmic microwave background, the faint afterglow of that first moment, which acts as a snapshot of the infant universe. Understanding this explosive origin is key because it explains not only how the universe began, but why it's still growing today. But the real mystery starts with the question: will this expansion ever stop? Is the universe still expanding? For centuries, humans have looked up at the night sky and wondered if the cosmos is static or changing. Then, in the 1920s, a groundbreaking discovery shattered old beliefs. Distant galaxies aren't just sitting still, they're speeding away from us. This phenomenon, called redshift, acts like a cosmic Doppler effect, stretching the light waves and proving that space itself is expanding. But here's the twist: this expansion isn't slowing down. Thanks to powerful tools like the Hubble Space Telescope, scientists found that the universe's growth is actually accelerating. The surprising culprit behind this mysterious force is something we call dark energy, an invisible energy making up about 68% of the universe and pushing galaxies apart faster and faster. Dark energy is baffling because we can't see it or measure it directly, but its effects shape everything from galaxy clusters to the very fate of existence. Understanding how and why the universe keeps stretching reveals not just where we are today but where everything is headed. The cosmos is far from static, it's an ever-evolving masterpiece, driven by forces we are only beginning to grasp. Theories about the universe's ultimate fate. When it comes to the universe's future, scientists have outlined 3 dramatic possibilities, each with its own cosmic drama. The first is the Big Freeze. Imagine a universe that expands forever, galaxies drifting so far apart that stars burn out, leaving a cold, dark emptiness. Over unimaginable eons, everything fades into silence as heat and energy dissipate. The second scenario, the Big Crunch, paints a very different picture. What if gravity eventually overpowers expansion? The cosmos could reverse course, shrinking everything back into a dense, fiery collapse, like rewinding the universe's own birth. Lastly, there's the most extreme and unsettling idea, the Big Rip. If dark energy grows stronger over time, it could eventually tear apart galaxies, stars, planets, and even atoms, ripping the very fabric of reality apart. Each theory depends heavily on the nature of dark energy and how it behaves over cosmic timescales. The fate of everything we know hangs in the balance between these incredible, mind-bending outcomes. What happens next might rewrite the story of existence itself. The role of dark energy. Among the most profound mysteries of the cosmos lies something both invisible and overwhelmingly powerful: dark energy. This mysterious force doesn't just influence the universe, it dominates it, making up nearly 68% of all cosmic energy. Unlike gravity, which pulls things together, dark energy pushes space itself apart, driving the accelerated expansion of the universe. Scientists first suspected its existence when they noticed galaxies speeding away faster than expected, defying the slowing effects of gravity. But what exactly is dark energy? Is it a constant, unchanging force? Or could it evolve over time, perhaps weakening or intensifying? These questions fuel cutting-edge research and debates in cosmology today. Understanding dark energy is crucial because it determines whether the universe will expand forever, collapse, or rip itself apart. Unlocking its secrets may not only reveal the fate of the universe but also challenge our understanding of physics itself. Dark energy remains one of the biggest enigmas, a ghostly presence shaping everything around us in ways we are just beginning to comprehend. Recent discoveries and changing perspectives. The universe is constantly surprising us, and recent discoveries have started to challenge long-held assumptions about its fate. Some new research hints that dark energy might not be as constant as once thought. Instead, it could be slowly weakening over billions of years, opening the door to a future where cosmic expansion could change course, or slow dramatically. This shift in understanding is shaking up cosmologists, forcing them to reconsider how the universe might evolve. Cutting-edge projects like the Dark Energy Spectroscopic Instrument are mapping millions of galaxies with unprecedented detail to track these subtle changes. These observations could redefine cosmic models and hint at new physics beyond our current theories. It's a reminder that the universe's story is still unfolding, and every discovery brings us closer to answering whether the cosmos will expand forever or take an unexpected turn. The journey to uncover our universe's destiny is ongoing, filled with thrilling discoveries that challenge everything we thought we knew. The uncertain future. The fate of the universe remains one of the most profound mysteries we face, an enigma wrapped in dark energy, cosmic expansion, and time itself. Despite decades of research and incredible technological leaps, scientists still don't have a definitive answer. Will the universe continue expanding forever into an icy, silent void? Or will it someday collapse back, triggering a cosmic reset? Perhaps it will unravel at its seams in a violent big rip no one has yet fully imagined. What makes this question so fascinating is how it pushes the limits of our knowledge and imagination, reminding us that we are explorers in an ever-expanding sea of the unknown. The universe's story is still being written, and every new discovery adds another chapter to this cosmic saga. So as we gaze into the night sky, let's embrace the wonder and uncertainty, because it is precisely this mystery that fuels our quest for understanding. The universe may be infinite, but so is our curiosity, and that might just be the greatest force shaping the future of all things. Thanks for joining this cosmic journey into the fate of the universe. If you enjoyed exploring these mind-blowing mysteries, don't forget to like this video, subscribe to Space Facts, and hit the bell icon so you never miss an adventure beyond the stars. Your support helps us bring more fascinating space stories right to you. Got questions or theories about the universe's future? Drop them in the comments. We love hearing from curious minds like you. Stay curious, keep looking up, and get ready for the next incredible adventure with Space Facts.